All right, so we are looking at PreAP physics, projectile motion, homework 6, number 1. It says a stone is thrown horizontally at 8 meters per second from a cliff 78.4 meters high. How much time does it take for the stone to reach the ground? How far from the base of the cliff does the stone strike the ground? What is the velocity? And that's going to be the magnitude and the direction of the stone when it does strike the ground. We're not going to work this exact one since it is due and you should get the practice, but we will work one that is very, very similar to that. So basically what we're looking for is we are given that we have we're just going to call it a cliff, right? And we have something coming horizontally off of that. All right, so in this case, it's going to move like that, and its trajectory is going to look something like that. Okay, so I'm going to come up with some numbers other than the ones that we had. I'm going to go ahead and say this is 90 meters. I don't know exactly what my answers for this are going to be because I'm just pulling these out of nowhere. And I'm going to say that its initial velocity, let's say, is 15 meters per second. If I know that the stone is thrown horizontally, then that means that my velocity is acting entirely in the x direction at this point right here. Okay. At the end, for part C for number 1, it says what's the velocity when it strikes the ground? Well, we're looking for the velocity right there. And that's going to be very different from the velocity up here because it's going to fall down and we're going to combine some vectors there. But for the first part, it says how much time does it take for it to reach the ground? Well, the x component of the velocity has absolutely nothing to do with how long it's going to take that stone to reach the ground. So what we're going to do is go ahead and write down our information in the y direction. Okay, and I'm going to start off with my position. I'm going to call that y sub I for my initial y. I'm going to call that 90 meters. I know at the end, I'm going to call that y final, y sub f, and I'm going to call that 0 meters. Now, if I want to find delta y, I know that delta y is equal to y sub f minus y sub I. So that's going to be equal to 0 minus 90 meters. All right, and that's going to give us negative 90 meters as our displacement in the y direction. Okay. We also know that in the x direction we have acceleration due to gravity is negative 9.8 meters per second squared. I know that time is what I'm looking for. I do not know the velocity at the end. And there's one more piece of information that we have here, and that is going to be velocity initial. And what I do know is this. If this is moving horizontally, it's moving in this direction initially, which means that it's essentially just falling to the ground. I'm not giving it any velocity at the beginning of the problem in the positive or negative y direction. So I'm going to say my initial velocity is 0 meters per second. So what that does, I'm going to go ahead and cross out my final velocity since I'm looking for my time. And I'm going to use delta y, acceleration, time, and initial velocity. And the equation that I have that has all 4 of those things in it is going to be delta y equals velocity initial times time plus 1/2 a t squared. Some of you guys are going to see this as delta y equals VIT minus 1/2 of gravity times time squared. If you do that, make sure you use gravity as positive, but I'm going to use this one because it's applicable to any situation with acceleration that's constant. So delta y is negative 90 for this one, so negative 90 meters equals initial velocity is 0, so that means velocity times time right here is 0, so I'm just going to go ahead and cross that out. So it equals 1/2 of negative 9.8 meters per second squared times time squared. All right, so I'm going to go ahead and write negative 90 equals negative 4.9 t squared. If I want t on its own, I'm going to say divided by negative 4.9 divided by negative 4.9. Okay, that cancels out over here, and I'm going to get t squared is equal to 90 over 4.9, which is going to be approximately 18. I don't have a calculator handy, so I'm just going to go ahead and call it 18 and then correct it on the next part. So I'm going to say that's approximately 18. So t is going to be equal to the square root of 18, which is going to give us some number, all right, in seconds. And that's going to be, you guys can't see that, that's going to give us the answer. So it would be part A for this one. We're going to look at part B in a second.